Perfect. The base meaning the core function, not the base, you know, we use the word base for two different things. Good. So what is the core function or the base function if you want here? Log base 2 of x. Awesome. Thank you. Log base 2 of x. Very good. Well done. And then what will be the first transformation? Moving to the left 4. Number 1. Left 4 because it's log base 2 of x plus 4. Very good. And what is the transformation 2 on function 1? What is it? Down 2. Very good. So log base 2 of x plus 4 minus 2 is down 2. Perfect. So now the question is, how do I graph? How do I graph log base 2 of x? How do I graph that? How do I graph the base function? The core.
Like this, right?
Yes, you're right. It's an increasing function. The inverse of 2 to the x. Very good. Awesome. Yes. And it crosses, don't forget what you want to ask, and it crosses where?
At the x-axis. It almost crosses the x-axis.
1 comma 0. It's the inverse of the exponential. So this is log base 2 of x. Perfect. It has to cross at 1 comma 0.
I have a question.
Mm-hmm.
Well, in my math lab, when you're doing problems like this, it's like when you go to graph it, it has the option of like doing that graph or it's upside down. Do you know what I'm saying? Like
if the base is greater than 1, the graph is increasing. If the base is less than 1, the graph is decreasing.
Okay, gotcha.
But because the base is 2, it's increasing. If the base were 1/2, the function would have been like this.
Okay. Yeah. I wasn't sure when like you switched it.
Perfect. Okay, then you told me to move this graph left 4. What do I have to move first? That will be the next step. What do I have to move first?
Asymptote.
Excellent. Where will I move it?
Down to
Where is the asymptote? Let's read the asymptote.
at
No. No, y equals 0 is this.
It's at x equals -2.
No,
X equals 2?
no. This is the vertical asymptote. Look at the graph. Look at the graph.
Is vertical.
Look at the
Y equals 0.
x,
Equals x.
right?
Straight down, right?
It's x equals 0.
Okay.
Because the function, if you remember, it's a function with restrictions. It's not defined everywhere. So I have to move x equals 0 where? Exactly, left 4. 1, 2, 3, 4. Now I move the point. Where do I move my marker? The 1 comma 0, where do I move it to? Yes.
Since the points are 1, 0 on the x-axis for that graph, when we move to left 4, would it be 0, 3, 0, -3, or no? Sorry, -3, 0.
Yes.
Okay.
1, 2, 3, 4.
Okay, that's.
So this is log base 2 of x plus 4.
Why is it on 5? Wouldn't that be considered 5?
1, 2, 3, 4.
Also about the x.
The 1, 2, 3,
Yeah, we
1, 2, 3, 4.
So the asymptote goes on -4, but from
0.
yeah, but not from the graph. 3, 4, and then it goes on 3.
1, 2, 3, 4.
Oh, I see what they're saying.
Yeah,
I see exactly what they're saying.
Okay.
You're saying exactly what they're saying too. Because when you counted a 0, 0,
This is 0, 0.
right. And then when you went over 4, that would have been 4. But then if you started at the first 1, the -1, and you went on the graph, it would have been, it looks like it's 5. So that's what they're saying. You see what I'm saying?
But how can it be 5 if this is -4 and this is -3?
It's two separate pieces moving. So the
Right.
asymptote moves
Never
4, so it ends up at -4. But the other one started at 1, so you start from 1 and then you subtract 4.
Right, I get
Yeah.
that, but
That,
I see what they're saying.
that's what it is. It's two separate pieces and it gets confusing with a lot of moving pieces.
Gotcha.
So the asymptote was at 0, it moves 4.
Okay.
The graph was this, and it moves 4 to the left.
Okay.
Is that okay? Okay, so now down 2. So where is my marker now going to go? -3, -2, awesome, right here. That's where it's going to move. I don't know where the function will cross. I'm going to graph this, but I don't know. I don't know if it crosses here, maybe it crosses here, maybe it crosses here. I will verify in a minute. So this is log base 2 of x plus 4 minus 2. I'll go back and make the necessary changes because the problem is asking me to find the x and y intercepts. We'll figure it out and come back and make the adjustments. So how do I find the x-intercept for any function or x-intercepts for any function? Say it again.
Set the equation to 0.
Very good, awesome. So I have log base 2 of x plus 4 minus 2 equals 0. Awesome. So the x-intercept requires y to be 0. Very good. I repeated it so many times, I'm hoping that everyone remembers. Good. So then what type of equation is this and how do I solve it? Awesome. Clean it up. Log base 2 of x plus 4 is 2. Very good. Awesome. Then change this into, say it again.
Exponential.
Good. 2 to the power of 2. Very good. Equals. Very good. 2 to the second power equals x plus 4. Good. So this is 4 equals x plus 4. So x equals?
4, 8, 0.
Very good. So 0, 0, I solved the problem. That's the x and the y intercept. My graph is no good. So it has to cross exactly at the origin. I will not erase anything. I will just go and do this. So this is the correct graph. This one. Because it turns out that the function crosses at the origin. Good. Is this okay?
Yeah, and the problem also says to identify the domain.
Oh, yeah. Very good. Thank you. So let's find the domain of this function.
So would you do like the x plus 4?
Exactly. Must be.
X equals -4?
Must be
X is greater.
greater than 0. So x greater than -4. Although I already see it. I see it has to be greater than -4. Right? So the domain is -4 to infinity. What about the range? The range, I have to look at the graph.
Infinity to
Exactly. The range is all real numbers. Very good. Which one? Number 3. Okay. We did that problem last time. Is the same problem is on the green form.
Or do you want like it then?
Is
But let's make one up.
this wasn't the same one on the green form, was it?
I think it's the same problem on the green form. If it's not, we can do this one.
No.
It's not? No. Okay then. Very good. So log base 3 of 2x to the 4th, the square root of x minus 1 over x plus 4 times 2y minus 1 to the 3rd. Okay. Where do we start? We're asked to expand using the properties of log. Where is the starting point?
You start with this square root.
Yes, which one? I have three properties. Indeed. The starting point is the division. Perfect. So how do I express this? Yes? Very good. Yes. No. Yes. Very good. X plus 4, 2y minus 1 to the 3rd. Awesome. Good. Next.
First, the square root.
Then we
Good. I have a product. I'm not at the power. I have not reached the power yet. I have to address the product now. Don't even look at powers yet.
That's log base 3, 2,
Log base 3 of 2
plus
mhm,
log base 3 of x plus
to the 4th plus
log base 3 of square root of x
minus
1 minus log base 3
of x plus 4.
plus
You have to distribute. This will be a plus, but you have to distribute negative 1. Log base 3 of 2y minus 1 to the 3rd. So remember what we said at some point in time when we were addressing this. If a quantity is at the top, each quantity's log will have positive in front. If the quantities come from, or quantity is coming, or quantities are coming, or quantity is coming from the denominator of the log, both in this case have to have minus in front because they come from the denominator. Or you say minus, you make this into a sum, but then you have to distribute negative 1. So if a quantity is coming from the denominator, it will always have minus in front of the log. So now I'm done with the ratio and then the product, and now I can take care of the powers. This is done. This is done. But this is a power that goes in front. This is another power. What power is this? 1/2 goes in front, and then power 3 goes in front, and this is it. So log base 3 of 2 plus 4, log base 3 of x plus 1/2, log base 3 of x minus 1, minus log base 3 of x plus 4, and minus 3 log base 3 of 2y minus 1. And there is nothing else we can do here. Yes.
this one, can you put this thing down? This x plus 4, 2y minus 1. I want to suppose to,
You're talking about this?
yes. Why did you put, okay, like, I know the minus is going to affect the ratio, but the bracket, is it not products? The x plus 4
Yes.
times 2y minus.
Yes, log applied to a product is the sum of logs, but I have minus in front that I have to distribute to both. So if you don't have this, you will have log of x plus 4 plus log of this. But this minus has to be distributed. It's better to remember like this. If the quantity is coming from the bottom of a ratio, definitely both have to have negative in front. If the quantities come from the top of the ratio, all those will have positive in front. Because otherwise, if you forget to distribute, then you mess up the problem. Correct. Yes. Yes. Any questions on this? Are we in the clear with this one? Okay, awesome. Good. Which number again?
Chapter 4, right?
Yes, all the logs and exponentials are in chapter 4. Yes.
Number 4.
Number 4 from the same form?
Yes, please.
Very good. So let's do that. Perfect. Number 4. So in number 4, we are asked to find the domain of the function f of x equals natural log of x minus 1 over 2 minus x. Perfect. So what do you think we need to do here? What do we have to write? Say,
If x is greater than 0,
what do I have to write?
x minus 1 greater than 0.
This is not what log is applied to. What is log applied to?
Equals to
What is log applied to? Just let's read. What is log applied to? Say it again. What is applied to? What quantity is log applied to?
X minus 1 over 2 minus x.
Exactly. This is the quantity that log is applied to. Log is not applied to the numerator.
It's the whole thing in the.
It's the whole thing. So then, what do I have to write?
greater than 0.
Exactly. Any quantity that log is applied to, but not portions, the whole thing, it has to be a number greater than 0. Awesome. Good. Now I'm going to ask myself, what type of inequality is this? Very good. Awesome. Now I have to ask myself the next question. How do I solve a rational inequality? What do I have to do to solve the rational inequality? What is the procedure?
Equals to 0.
Say, no. I know you know because every time we did this, something similar, you remembered. Say it again. No, I'm not. I didn't hear. I'm still clogged up from the illness. I can't hear well. No, this is an inequality. It's rational.
Don't we have to graph both of them to see which one?
The
Is it
table,
common?
very good. The table, yes. Yes. So x is the variable in the problem. X minus 1, 2 minus x, and x minus 1 over 2 minus x. Indeed. That is the procedure.
From the last test,
Yes, you always, yeah, that's what it is. You can escape. You can't escape.
the final exam.
No, you can't do that. Yeah? Okay, so which numbers go in the chart? Which numbers go in the chart?
1 and 2.
Exactly. Indeed, 1 and 2. There must be a 0 for the row of x minus 1. Somewhere there must be a 0.
So it wouldn't be negative 1, it would just be that.
2, okay. X minus 1 equals 0 means x equals 1. And 2 minus x equals 0 means negative x equals negative 2, which is x equals 2. Linear equations, please. Please, linear equations. Okay, so there must be a 0 for x minus 1 somewhere. Good. There must be a 0 for 2 minus x somewhere. Very good. What happens to this fraction under 1?
Wait,
What happens to the fraction under 1? Right, because the numerator is 0, the fraction is 0. Awesome. What happens to the fraction under 2?
Undefined.
Thank you very much.
Wait, why did you put 0?
When the denominator is, a fraction is 0 when the numerator is 0. And a fraction is undefined when the denominator is 0. Is that okay? Is that okay? Okay, so x minus 1 over 2 minus x. If the numerator is 0, 0 over 2 minus x is 0.
Okay, why did you put this little square
This one?
What does that mean?
That's the those undefined.
Okay, I'm just,
I think
I write
that's-
mine differently, I'm just asking.
It's all good.
What is the
So
whole-
x minus 1 over 2 minus x, when this is 0, this is undefined.
I just write mine differently, I'm just asking.
Because we wrote this like 30 times in the charts for rational functions and okay, so let's go back to x minus 1. So what is the end behavior or the sign for x minus 1? Is it a line with a positive slope or is it a line with a negative slope?
Negative.
Yes, negative and positive, very good. Or just pick a number. You don't have to think in terms of end behavior or slope. I'm showing this because it's so much easier, but you may say, no, this is not easier for me. Pick a point. Pick a point from here, plug a number from here, plug it in, pick a number from here, plug it in. You'll see negative here and positive here. You don't have to use, yes, Damon?
I mean, so you just saying just pick a negative number to go with.
I have to pick a number between negative infinity and 1. Negative 100. Negative 100 minus 1 is negative. I have to pick a number between 1 and infinity. 100. 100 minus 1 is positive.
Right, gotcha.
So you don't have to think in terms of end behavior. Since we use that so much, I'm showing,
Yeah, I like
I
that.
look silly. I look silly showing this, but you don't have to. Use the method you like. Okay, what about 2 minus x? Plug in a number between, just you tell me. Do it the way you like. So pick a number from negative infinity to 2 and tell me the answer. Correct. Of course, because it's a negative slope and it has to look like this. It's coming from positive and going to negative. Absolutely. See, picking a number may be more difficult than thinking in these terms. Okay, so then we divide a negative by a positive. Awesome. We divide a positive by a positive. Awesome. A positive by a negative. Awesome. So now, only now, I'm asking myself, what do I do? What do I pick? Which sign is greater than 0? Exactly. Is this ratio ever positive? Yes. Infinitely many times, actually, between 1 and 2, there are infinitely many numbers. So indeed, the domain of this function is 1, 2. I cannot choose 1 because it's not the equal symbol. I can not definitely choose 2 because it's undefined. Very good. Good pick. Next question. What about,
Five.
say it again,
Five.
number 5.
This is worth more than 4.
Yeah, we did the same, wasn't that the same problem on green sheet? Yes. Wasn't it the same problem also on 5B? What about,
12.
okay, 12. 12. No, 12 is not part of your test.
Can you make up another one like that one?
Which one?
On 5,
Which one?
7. I'll try.
no, I'm saying 5, question 5. Can you make
Is
up
it
another
5A? Is it
5A,
5B?
5B, or can you make up
Oh.
something like that?
Sure. Okay. So let's say 7 to 2x minus 3 equals 11 raised to negative x plus 4. 4A, similar to 4A. 5a, I'm sorry.
Okay,
Yes, yes, similar to 5a. Okay, so my first question here is, what type of equation is it?
Exponential.
Exponential. Can I present, my second question is, can I present 7 and 11 with the same base?
No.
No. So what is my only escape here?
There's no parallel.
Very good. Either natural log or common log to both sides. Very good.
You would have set them the exponents equal to.
Careful. So if I have 2 to this equals 2 to this, then yes. Because the explanation is this. Two numbers are equal and they have the same base.
Oh, they don't have, okay.
Right. But because it's 7 and 11, I cannot do that. Because they are not the same base. Good. Say it again, Vincent.
Okay, that's what you just repeated. I got it.
Okay. So then, how do I continue here? What is the next step?
2x minus 3.
2x minus 3 in parentheses.
Natural log
Very good. Equals. Awesome.
negative x.
Negative x plus 4. Natural log 11. Perfect. Then,
Divi- divide by
I cannot.
You combine.
I cannot.
Can you put the, I don't know.
You know that equals
I cannot. Of course. Thank you very much. 2x natural log 7 minus 3 natural log 7 equals negative x natural log 11 plus 4 natural log 11. Very good. Yes, it's the only way. Because there is x on both sides. Otherwise, I could have possibly divided or who knows. But as long as I have x on both sides, I have to move terms around. And if I don't distribute, I won't be able to move terms around. Good. What will be the next step then?
like
I don't have like terms. So what will be the next step before we even talk about like terms? What do you think?
You can't divide.
Yes, rearrange. What do you mean by rearrange?
x.
Yes, yeah, this term has to follow that term, and yes, awesome. 2x natural log 7 plus x natural log 11 equals 3 natural log 7 plus 4 natural log 11. Question, why did we do this one more time? Can anyone explain? Very good, to get the terms with x on one side and the terms with no x on the other. Awesome. Very good. Always remember 3 concepts. If you come out of this class with 3 concepts, I will be very happy. Factor, simplify, clean it up. Okay, so what do you think will be the next step? Clean it up. How? It's not clean it up, but it's one or the other two. Say it again. I cannot. Say it again. I cannot. They're not like terms. This is like y and this is like z. 2xy plus xz are not like terms. Yes, what? Awesome. Exactly. Very good. So then what is left? Two natural log 7. Very good. Plus natural log 11. Very good. Finally, x. By? Exactly. 2 natural log 7 plus natural log 11, 3 natural log 7 plus 4 natural log 11. Very good.
Which section will this be in?
This is in section 4.4, exponential and log equations. And I can indicate an example. We did in class at least 3. So it's 4.4, and I will give you a couple of examples. For example, 41 and 42 on page 514. They're very similar to what we just did. Okay, next problem, next question, anything else you want? Anything else? Anything from 8.1? 8.1 is with sequences.
Can we do the one where it's, I don't remember the name of the section, but it's like the A0 over 2.
That ain't that one.
That is that one?
Uh-huh.
Yeah, that.
So, okay, so for example, finding the first 4 terms or 5 terms of a sequence, or using the summation notation.
I'll show you. I'm not sure.
Oh, yeah.
I know what the problem is.
That's
but it's
the
like
best
ones
thing.
like this.
Oh, the word problems. These are in section 4.5.
Okay.
Yes, of course. The exponential growth and decay. Yes, of course. Okay, on page, you want the logistic growth model, or you want an exponential growth model?
Exponential.
Exponential growth model, very good. So I'm looking at the review for that test for an exponential growth model. I found an exponential decay, but you want an exponential growth.
I mean, either or, I could probably practice one, honestly.
Okay, very good. In that case, let's work on problem 80 on page 537. Okay, the function p of x equals 14.7 times e to negative 0.21x models the average atmospheric pressure p of x in pounds per square inch. So this is the pressure. At an altitude of x miles above sea level. X miles above sea level. I have to take notes when I read. The atmospheric pressure at the peak of Mount Everest, the world's highest mountain, is 4.6 pounds per square inch. 4.6 pounds per square inch. Okay. How many miles above sea level to the nearest tenth of a mile is the peak of Mount Everest? We'll find another exponential growth in a minute. Good. So we are told this is a relationship between the pressure and the miles, the altitude in miles above the sea level. So when x is blah, p of x will depend on whatever x I choose. So now we are told that the pressure is 4.6 pounds per square inch at the peak of Mount Everest. We would like to determine how many miles is that above sea level. So what is given? What do I have to write? What am I solving for? What do you think? Yes, we are solving for x. Awesome. So what do I have to write? Exactly. Equals 14.7 e to negative 0.21x. Awesome. What type of equation is this? Good. Is it cleaned up? No. It needs one step. What is the step that it needs? Exactly. 4.6 divided by 14.7 equals e to negative 0.21x. Awesome. Good. Now, can I present both sides with the same base? Absolutely not. So then what is the only choice? Excellent. I apply natural log to both sides. I get natural log 4.6 divided 14.7. Do not attempt to simplify. There is no need. Equals negative 0.21x. Finally, I can find how high, how many miles above sea level is the peak of Everest. Very good. Natural log 4.6 over 14.7 divided by negative 0.21. Awesome. So with the graphing calculator, I'll do just that. So natural log 4.6 divided by 14.7 and divide everything in parentheses by negative 0.21. And the answer is quite high, 5.5 miles. It wouldn't be that bad, but you can't breathe.
It didn't circle.
Oh. Very good question. Let's also look at another exponential growth model. It's amazing. I can't find if there is logistic growth model.
About page 72.
Oh, but we have a problem here.
Oh, okay.
We have a problem here. So here it is. So problem 6.
Problem 6.
The stray cat population grows exponentially in a small town. In 1999, the town had 30 stray cats. What is that? I'm sorry.
Great case.
Sorry about that. And the relative growth rate was 15% per year. So we are told that in 1999, there were 3 cats, and the relative growth rate was 0.15. Find the function. The model will be given to you. So this is a of 0 e to rt. So a of t equals a0 e to rt. So I have the exponential growth rate, which is this. Do I have a0? Yes, so it's 30. 30 e to 0.15 t. So that's the exponential growth model. The initial number of cats is 30, and the growth rate is 0.15. Find the projected population after 4 years. How do I find that? That's it. A of 4, and let's use the graphing calculator for that. So we have 30 times e in parentheses, 0.15 multiplied by 4, close the parenthesis, and enter. So I cannot round up, even if I have 54.6, because if I have 54.6, I don't have 55 cats. So I have to say 54. Yes. We're talking about animals and people. I can't. Find the number of years required for the stray cat population to reach 500. Awesome. 500 equals 30 e to 0.15 t. What type of equation? I know I sound like a broken record. I always do. Forgive me for that. But this is how we remember step by step what we need to do. First, I'm looking at it and I'm saying, what is this? Oh, it's exponential. Then I'm going to ask myself, is it ready for what I should be doing? Well, the answer is no, it's not ready. Very good. So I have 50 divided by 3 equals e to 0.15 t. Now, is it ready for what I need to do? The answer is yes. I apply natural log. So, natural log of 50 divided by 3 equals 0.15 t. How come that I don't write multiply by natural log e? Because it's 1. Very good. Awesome. Thank you. So finally, t. So how long it will take for this population to grow to from 30 to 500? So what do I write? Exactly, awesome. Thank you very much. 50 over 3.15, awesome. So again, I need to use the calculator. So I have natural log 50 divided by 3, close the parenthesis, and divide by 0.15. So it takes roughly about 19 years. So I will have to add 1999 to this, and it's roughly 2018. So
You round up all the time?
the years, yes, I can. But people, animals, no, I can't. Money, I will possibly round up depending on what we're doing. But when it comes to living creatures, no, I can't.
So when you look at you said number of years, trade population to reach 500.
Yes, because we started in 1999.
Right, but what if you did 50 divided by 3?
Why we did that?
Yeah.
Because